My fellow woodworkers, you may notice that in this episode, my beautifully groomed goatee has gone missing. The reason? My wife Nicole forced me to shave it. Well, no more, I say. No more! Far too long have we lived under the oppression of our wives and girlfriends. No longer shall we walk around our shops baby-faced and pale simply because we've bent to the will of what I now call the oppressive establishment. It's the dawning of a new age, my friends, when men shall be able to wear whatever beard they choose. Short or long, our beards will be the finest pieces of craftsmanship to come out of our shops in years. Grow what you will, my friends, and grow it with pride. After all, if we weren't meant to grow it, hair wouldn't grow there. Just be careful with that logic because it could be used against you. So with that, I say...
Mark, it's time for your shave.
Man. So now I'm going to start cutting my rough parts out of the boards with a jigsaw. Now why a jigsaw? Well, most of the time with these rough boards, they're not perfectly flat. So if you put them on a miter saw or some other tool, they kind of wobble a little bit. And I've had some bad experiences there. So I really prefer the mobility and the safety that I get by using a jigsaw. And quite honestly, a lot of times it's faster. So my setup here, I just have two simple roller stands that are slightly lower, about a ½ inch lower than the table itself, so that I could set everything up this way. We'll clamp the board down and just make our cut across. This piece will safely drop. The idea is if you only have one stand here, it's probably going to pinch the blade or fall down on the ground. And I don't want it to fall, I want it to be supported. So let me clamp this down and we'll make those cuts. Now I'm going to mill the rough boards to their final length, width, and thickness using the jointer, the planer, and then the table saw. Now if you're not familiar with that process, go back and check out episode number 6, The Joiner's Jumping, and that will give you a full review of the entire process. Now with the sides and the top and bottom pieces milled to size, we can start focusing on the joinery, the way that the top is going to join to the sides. Now the joint that I'm going to use is more or less a modified green and green sort of box joint, where it's just a set of interlocking fingers that protrude about a ½ inch from each other. Normally we try to get these joints, if they're like dovetails or box joints, you try to get them nice and flat, but in the green and green style, you'll notice that they always seem to protrude a little bit, which gives it a really good three-dimensional sort of element to it that's really cool. So I'm going to reproduce this type of joint exactly as you see it here in some test boards. Okay, we're going to use the table saw to do it.
I start by carefully laying out my joinery using X's to mark the waste areas. I prepare my miter gauge by applying a piece of 1/4 inch plywood with double stick tape. This actually helps to prevent tear out. Now using the workpiece itself as a guide, I set the height of the blade and the position of the fence. I then clamp the workpiece to the fence for added safety and proceed with my first cut. Just make sure the clamp isn't in the path of the blade. After flipping the piece around, I can make my second cut.
Now we've done all of our vertical cuts in both the top and the bottom pieces. And the reason we do it this way is by keeping everything set up and not changing the setting and batching out all of those cuts in one shot, it increases our accuracy and just gives us better results. So now that all those cuts are done, we can focus on the second part of the cut, which requires the workpiece to be horizontal. We actually want to remove this whole piece here on both sides, leaving us with that singular finger in the middle. Now the way that I do this is again using the miter gauge and the fence to guide the cut through. But what do we have here? This is a special situation because now the piece is going to come off. We're not just doing a kerf cut, we're actually going to remove a piece of material. And if that gets wedged and sits just loose, the vibration is going to cause it to get wedged between the blade and the fence, and it's going to shoot behind us like a missile. You definitely don't want that to happen because that's a recipe for disaster. So what we need to do is use an auxiliary fence. Now this one is just a very simple fence built out of 3 pieces of plywood, and I've got just, this is something you don't even necessarily need to do, but it works well for me. These little twisty dealies put pressure on the outside of the fence here and gives me a little bit tighter of a grip. But it's a pretty good slip fit anyway. You keep this behind the blade, or I guess in front of the blade, and use that as your fence so that by the time you actually touch the blade, that little cutoff piece is going to have enough room to swing around in there safely. Now, even though the auxiliary fence does make this operation a lot safer, there is still a risk of kickback if the diagonal of the cutoff piece is long enough to contact the fence and the blade. And I had a conversation recently with a friend of the show, Marty, who had some great ideas on how we might be able to handle this. And the primary thing he suggested was to put some sort of a fence, anything really, a scrap of wood, with a clamp it to the table and use that as a free floating fence. Get rid of the main fence altogether so that there's nothing in this area to cause a problem. Great suggestion, but I think one thing that might make something like that a little bit easier to do is if you make your own little jig from a magnet, or like this little mag switch, little dilly whacker thing. This can go at any point, anywhere you want on the table. You just turn the little handle and the magnet's engaged, and that thing isn't moving anywhere. So if all you're doing is using it as a reference and a guide to tell you where you want to start and line up your cut, you can do that, clamp it down, and make your cuts. So this is definitely a major improvement in terms of safety over just using the auxiliary fence. But I have used the auxiliary fence method for years and haven't had any major problems. Maybe I just got lucky, but you want to make sure you pay attention to that diagonal length so you know what you're in for.
Once again, I use the workpiece to set the blade height. Don't press your luck here, just raise it high enough so that the little block falls off. We'll clean up the corner later. And this time I'm going to use a mag switch magnet instead of my fence. This worked pretty well, you just have to be careful that you don't knock the magnet out of place. But as you can see, the offcuts present little to no kickback risk.
Now we're done with our top and bottom pieces for now, and it's time to move on to our side pieces. And it's going to start much the same way that the top and bottom did, with a couple vertical kerf cuts. Only this time, it's a good thing we put these X's here because this is when you could really get confused. This time we're going to remove the material inside of these lines, okay, from the middle here. Now I could just take my side pieces, start making my cuts, and hope that my pencil lines were dead on, and see how the fit is. The problem with that is usually you're not going to come up with a great fit. Either you're going to be too loose or too tight. And really, at least in my shop, the best way to do this is to do more of a trial and error fit. To purposely cut it so that the joint is a little bit tight, and then slowly but surely sneak up on it so that you get the perfect fit. And I find it a lot easier to do this and a lot less risky if I'm using a piece of scrap for that instead of using my final work piece. So I have a piece that's cut to the same exact width as my bubinga board, only this is just an expensive piece of alder. You can see I've already used it for experimentation. And I should be able to make some practice cuts this way, get the fit just right, and then go back to my bubinga board.
Much of this process is the same as before. Just remember, you're now cutting inside the line. Now the bandsaw does a fine job of cleaning out most of the waste. The first test fit is a little bit tight, so I quickly adjust the table saw fence and cut each side again. This time, it's a perfect fit.
All right, so now we've got a nice fit, but before we make this cut, we do have to turn our attention to one more detail, and we have to think ahead a couple steps. When we remove, well, here's another practice piece. After we do these first 2 curve cuts, just like we just did before, we can remove the excess with the bandsaw, but we'll still be left with a really rough back end to the joint. So we need to handle that. We need to think ahead how we're going to remove that. And I'm going to use a chisel to do it, much like cleaning up a set of dovetails. And what I find easiest to do is give myself a scribe line at the back ahead of time, and I could set my chisel into that scribe line and drive straight down. It makes the whole thing a whole lot easier. But once this material here is gone, it's not very easy to make that scribe line anymore. So what I suggest doing is making the scribe line now while the piece is still together and whole. And you can use one of these simple marking gauges like so, and just really, you only have to get the middle. You don't even need to go all the way to the line, because once you have most of that established, the chisel can just cross over and get the rest of it as well. Okay, so use a marking gauge or even just the straight edge and a X-Acto knife or a razor knife of some sort, and make that cut so that you at least scribe the line enough that you could fit a good sized chisel in there.
I cut the bubinga boards in the exact same way as the test piece.
Now there are a lot of ways that we could have cut these joints, but for me, the table saw method is just really quick and really accurate, and leaves me with nice smooth edges here that don't really need any more work. And in fact, half of our joints, all of this type of joint for the top and the bottom, they're almost done. All I really need to do is make a few taps this way cross grain, and then another tap or 2 this way going with the grain, and it knocks that little nub that's still left there. And that's a small price to pay for being able to go this quickly and get all those joints milled accurately. Now the other ones are going to take a little more time, but at least half of my joints are done at this point. So what I usually recommend doing, getting a nice wide chisel, and you want to reference off of the flat surface here. Keep your chisel nice and flat and give it a few taps across the grain. Now the reason we go cross grain first is because if we went with the grain, there's always a chance that we could split it. That's the way that the wood wants to break apart. So we slice those fibers cross grain first, then we can go with the grain. And that little piece should just pop right out. Perfect. Now the side pieces are going to be a little bit trickier, because now we have to remove a good amount of material in the center here. So I've got my side piece clamped down to the workbench with a sacrificial surface underneath, just in case my chisel goes all the way through, and we're going to carefully start removing some of that material.
I usually start by putting the chisel in the little groove that we created earlier. A few taps here and there will give us a nice deep reference line. From there I start chiseling away the waste, but I only go halfway down. Going any further could result in a mishap that would be visible from the other side. And after flipping the board over, I use a large chisel to establish the border line on that side. Then I chisel away the other half of the waste. Notice that I'm removing some of the excess before I actually chisel directly on the line. In a very dense wood like bubinga, this is going to make the chiseling go a little bit easier and should prevent you from having to bring out the sledgehammer. My final pass is right on the line, and as you can see, still requires a good bit of effort to push through the bubinga. Now, since the likelihood of chiseling perfectly straight is pretty slim, I like to err on the side of caution and angle my chisel slightly inward. The key to this joint looking good is perfection at the edges, not necessarily perfection in the middle. So if the middle is a little bit scooped out, that's okay. It's a good idea to check your progress with a square just to make sure everything is going according to plan.
So with all of our joinery cut, we can finally do a dry fit. Now this will be one of many dry fits on this project, because there are just so many things that I need to have part of the cabinet together before I can determine the length, the width, or the location of certain things like shelves and the back panels. So the next step here, and you can see that I've actually labeled the heck out of this thing, I usually take a piece of chalk, and once I have my grain orientation the way that I want it to go, I want to commit these pieces to their location so that we cannot mess them up in the future. So I'll mark a board as top, bottom, left, right, inside, outside, front, back. just to make sure that I do not screw it up and I know exactly where those boards are going to go in the future. And that's critical because the next thing that we need to do is put the holes on the outside for the pegs, so that when we screw these things together, we can cap them off with a nice ebony plug. So to get that right, we have to make sure we're drilling from the appropriate side, and we want to make sure that those pegs are centered. Remember, our boards extend beyond each other, so we have to mark the location of these boards so we know exactly where to place that plug. So that's what I'm going to do now. I just use a square and extend my lines. Very simple. Now to make our square holes, I'm going to use the hollow chisel mortiser. It's basically like a drill press, and instead of just having a bit by itself, it's got a bit that sits inside of a square chisel so that you can actually plunge out most of the material and then chisel it square. Perfect for what we're trying to do here. Now I also have a piece of scrap from when I was testing out the cuts at the table saw, which is going to be perfect for me to do a few test cuts and make sure that everything is aligned and going in the location that I want it. And I highly recommend using stop blocks when you do something like this, so you can quickly switch from one side to the other and not have to worry about completely redoing the entire setup each and every time. All right, the sample looks pretty good. At this point, you might just chisel out some of that material on the inside just to make sure you get full penetration of the peg and the screw. And there's a little bit of burning. Now with hardwoods, you kind of expect that. There's just so much heat and friction that it builds up, and it does burn the wood a little bit. As long as it doesn't really affect the surface at the top, that's usually fine. So now the only thing left to do is grab the actual pieces and start making the cuts. So no guts, no glory. So I know at least a few of you are going to be interested in how this huge mortiser actually works. I have one stop block, well in this case it's a built-in stop that's set up, and I can move the head back and forth with this big arm here. In the back there's preset locks that I could put to lock the head in preset position. So I basically loosen the head so that I can move it. We're going to put it into position 2. When it hits the stop, I'm there. And I've already set these up earlier. Lock the head in place, and now I can make my second cut. So that was obviously the harder of the two. The next one only has one, and it's located in the center, so that's going to be relatively easy to set up, so I don't need to show you that. What I will show you though is if you don't have one of these machines, what you can do to create this hole for your pegs. Now, if you're really good with a chisel, all you need to do is put your layout lines down and start chopping away. But you've got about 12 of these to make, and plus we're going to have some of these to do on the doors as well. And that's a lot of little squares to do to get perfectly right and perfectly consistent from one to the other. So if you don't have the hollow chisel mortiser, you can still buy these mortising chisel sets. Usually they come in a pack of 3 or 5, and they're not that expensive, and they're actually great for creating perfectly square outlines, and then you can use your chisels to clean everything up. So let me show you how I do that.
It's really as simple as lining the chisel up with your layout lines and giving it a few taps. A small chisel does the rest of the work.
And now for the easiest part of the whole project, drilling the pilot holes.
Now the final thing we need to do is round over the edges of the joints. I really prefer the look that you get when you do this by hand, and there's a number of ways that you can accomplish the task. The first is to simply use a block plane. Follow that up with some sanding. A second method would be to use a cabinet maker's rasp, and again follow it up with some sanding. Either method is capable of yielding stunning results and joinery that you can truly be proud of.